Hi friends, welcome back. Today we are going to solve one very recent and popular Leetcode coding interview question 2502 design memory allocator. As you can see, this is a medium complexity coding interview problem. Another quite recent and interesting coding problem. So we'll go through the problem statement first, then we'll go through some examples. We'll understand what the problem is first, and then we'll go through the Java solution code. If you are a fresher, junior level developer, mid-level developer planning to take any coding rounds of interviews, then make sure you watch this video until the end so you completely understand the logic as well as the Java solution to solve this coding interview problem. So let's start. You are given an integer n representing size of 0 index memory array. All memory units are initially free. You have a memory allocator with the following functionalities. Allocate a block of size consecutive free memory units and assign it to the ID MID. So let's say this is a memory allocation ID or something you can say. Free all memory units with the given ID MID, right? This is another functionality, and note that multiple blocks can be allocated to the same MID. Okay, you should free all the memory unit with MIDs even if they were allocated in different blocks. Okay, so now you have to implement allocator class. So this is the allocator class that we want to implement. This is the constructor you can see here, right? The constructor is there, then allocate method is there, and free method is there. So let's understand what those methods are. Initializes object with memory array of size n. Okay, allocate size and MID. Find leftmost block of size consecutive free memory units and allocate it with the ID MID. Return the block's first index. If such a block does not exist, then return -1. So this is for the allocation, right? So we want to allocate a block, right, for that much size with this MID, right? So this is for allocation, and int free MID will free all the memory units with the ID MID. Return the number of memory units you have freed. Okay, so that is the free method. Okay, so this is the example they have given us. N size and MID will range between 1 to 1000 inclusive. At most 1000 calls will be made to allocate and free method. Okay, so let's understand this problem with this same example that they have given us. So we took it over here. So the allocator has a 10 blocks, right? So this is the constructor first thing, and 10 blocks are there. Initially everything is empty. It will look like this basically, right? So you have everything is free, right? Okay, now you want to allocate a block of size 1 and you want the MID 1 basically. So you will put that here basically, right? Leftmost is this one, correct? So you will put 1 here basically, correct? So that's what they are saying. So the leftmost block, the first index 0, the memory array becomes 1. You return 0, right? The index you return left index, right? And you put that 1 here just like we put here, right? Okay, so let's keep going. So allocate 1 comma 2. So you want to allocate one size block to the MID 2. So basically you will put 2 here, right? This is another MID now for this block. So because this is the leftmost block that is available, right, in this block. So the index is 1, so 1 is what you will return now, right? You return 1. Again allocate 1 comma 3. You want a size 1 block and you want to put it 3 there. So this is where you will put 3, which is this place. So you put 3 here, right? So far so good. You got this clearly. Okay, now you want to free the location at 2, correct? You want to free the location to free all memory units with MID 2. As you can see, the memory array becomes this. We return 1 since it is the only one unit with MID 2, right? Okay, so now if you want to free 2, then 2 is located here, right? So you want to free this basically. So what is the index? 1 is the index. So 1 is the index that you will return basically, correct? So that's what they are saying, right? So let's take a look at free. So free, how many units we have freed? 1 unit we have freed, right? So it will return 1. So let's remove this now. So let's use this eraser so we can remove this, because now anyway we are not having it now, right? So we'll remove this 10. Okay, so now this one again became free. So now keep going. So now we are here, right? So now we want to allocate 3 units to a 4. 3 units. So this one we cannot use, it's only 1 unit, right? So these are the 3 units that we have now on the left side, right? So we will use these units. So we'll put 4 here basically, right? 4 here, and the leftmost ID you have to return, so you will return 3, correct? So that's what they are saying. As you can see here, you put 4 and you are returning 3, right? Okay, allocate 1 comma 1. So you want to allocate 1 unit to MID1. So 1 unit to MID1 is this one, because this is available. So you will allocate it, you will return this one, correct? So you can see that you allocated it here and you are returning 1, which is correct. Allocate 1 comma 1, again you want to allocate 1. So now 1 will be here now, then in that case, right here. Let's make sure that we are correct. So yes, we are correct. 1 is here, you will return 6, right? 6 is the index. Okay, so now you want to free 1. So everywhere you have 1, you will free it. How many ones are there? 1, 2 and 3. So we are going to free these 3 cells, and we have how many cells we have freed? 3. So you will return 3 basically, correct? And you will have empty there, so you are going to erase it basically now, right? You are freeing the 1 means everywhere, wherever is 1 you will free it. So this is the 1, right? This is the 1, so you will free it. Okay, now let's keep going. Now you want to allocate 10 units to 2. So you don't have consecutive 10 units here, right? So you will return -1 in that case. So you are returning -1. You want to free 7, but 7 is not there to free here, right? 7 is not there, 7 MID is not there. So in that case you will return 0, because you did not really freed up anything, because that MID does not exist, right? Okay, so now you understood this example clearly with this explanation and with this image, I hope so. Now how can we solve this problem, right? So we are basically using as array. Basically we will create an array of size n is 10 in this case, correct? And whenever we want to so freeing a memory is very easy. You will go through the array, and wherever you see that ID, you will just remove that ID and you will just count it. For example, you want to free 4. Let's say you want to free for the MID 4. So you will remove this 4s and you will count how many you have removed. 3, right? 1 2 3, and just you have to return it. So freeing is a very easy operation. Allocation is also easy, but you have to, what we have to do in allocation is you have to count out that many blocks should be there consecutive, right? For example, now you have let's say you want to allocate number 5 MID. So your MID is number 5, which is memory ID is number 5, and you want to allocate size 3 here. Okay, so you want to allocate size 3. So you obviously cannot use this because this is only size 2. So you have to find out a place where you have a consecutive block of 3, and it should be on the leftmost side consecutive block of 3. So this is what the consecutive block of 3 on the leftmost side here, right? And that is where you want to put this MID, correct? So this is what we have to do when we allocate it. So we have to find out this location. We'll find out this index, right? This index we will find out. We'll call it as an ending index, right? This is an ending index. So now if we know this ending index, then we can just decrease it by 3 units, and I can put 5 here, right? So that we will have consecutive 3 5s basically, correct? So this is for the allocation. So I think more we can discuss through the code only. We can directly go to the code and discuss it there. So this is our code for allocator. So we are going to use array. So allocator is the constructor, so we are going to create an array of size n, right? Okay, this is the important method allocate. So allocate, we want to allocate this much size for this MID, right? Memory ID. Now k is equal to 0, ending index is 0, flag is false. So these variables we have created in the beginning. Now we are going to go through the for loop from 0 to the end of the array I plus plus, and we are checking if it is 0. Array of I, if it is 0, it means that that is a empty location, basically, correct? It is a empty location. K will increase, right? And we will check if we find out a consecutive this size block, right? We want to find out this much size block which is consecutive, right? Because if it is consecutive, then only we can put that block in that consecutive memory space, right? So that's why we will check if k is equal to size. K will tell you our current size of the block. If it is equal to the size of the block that we want to put this block here, right, then it means that we found out a place where we can allocate that much block size to this current allocation, right? Then we'll make flag is equal to true, we'll capture the ending index and break it out. So as the comment says, check if we found consecutive empty slot that can fit this block of size. If yes, then take the ending index and break. And this is obviously you will get it on the leftmost side. Why? Because you are going from 0 to the end of the array. So you will find out that block on the leftmost side. Correct? Okay. You got it, right? So this is what they are saying. Find the leftmost block, right? So this is important, of size consecutive free memory units. Correct? Because for example you want to allocate 3 units, so you can allocate these 3 units also, right? You can allocate these 3 units also, but this is not what we want. We want to find out leftmost block. So leftmost block will be this one with consecutive 3 units. This one is only 2 units, so we cannot use this block for 3 units, right? So this is the leftmost consecutive block. So our ending index will be this in this case, right? This is our ending index basically, correct? That we'll find out, right? So that's what we are doing here. So this part is clear to you, I hope. So otherwise k will become 0, right? Because if it is already occupied by some MIDs, then you don't have any consecutive size, so your k is resetting to the 0, right? We are resetting it to 0 here. Okay, so this for loop will try to find out the ending index. If you find out that kind of a block which is available, your flag will be true and you find the ending index. If you find the flag true, you will check. Now it means that you can put this MIDs into that consecutive size of block. So you are allocating the memory from ending index going backward until it completely fits the block size, correct? So you starting here now and you start putting 5 here, right? You want put memory ID 5 here, 5 here, 5 here. How many times? Until your size is 3. So this is the exact 3 size that you will get basically, correct? Because we have found out this block which is of size 3 and on the leftmost side, right, through the code. So while size is greater than 0, you start putting MIDs to that array in the at the ending index minus minus, so it will keep decreasing. So you are going from right to left and size minus minus, right? Okay, so you are allocating the memory here. At the end you have to just return the ending plus plus ending index, right? Because you have subtracted it one more time, so you have to do plus plus here. Okay, so if the flag is false, it means that you never find out a consecutive block of that size, so you cannot allocate it basically, right? So you will return -1 in that case. So I hope it is clear to you now. This is not that difficult. It's just like we are just finding out. We are going from first we are going from right to left and finding out this location where we have consecutive block size available of 3 units. For example, in this case you will get this consecutive block size, right? 3 units, and then you will put 5 here, right? 5 5 5. So you are going to start putting 5 from right to left. Okay, so this is clear to you. Allocate now. there is a free method where we want to free up a specific memory ID, right? So count is 0. You are going to go through the complete array here. Whenever you find out that MID, you will just increment your count and you will reset the value of that block to 0, right? Because you want to free up the MID, free up that block, right? And at the end you have to just return the count. Count will tell us how many blocks you have freed in the free memory, in the free method, right? Okay, you clearly understood this code. Now order of n is the time and space complexity for this code. So let's go ahead, execute this code, make sure it gives us correct answer. As you can see, our output and the expected output is matching correctly. So we'll just go ahead, submit this code to the Leetcode, make sure it gets accepted. As you can see, the code is successfully accepted by the Leetcode. It is 33% faster on the performance side and 50% faster on the memory usage. So I hope you understood this array based implementation of how to design memory allocator, a Leetcode 2502 medium complexity interesting coding problem. So I'm going to add this Java code in my GitHub repository and give you the link of this code so you can check it out. There are lots of other important algorithms and Java solutions which are already implemented and available there for you. Don't forget to check out the other Java solutions there as well. It will help you learn more Java programming and coding. If you like the Java solutions in the GitHub repositories, consider giving it a star on the GitHub repositories. That would be great. If you are new to this channel, we have created a very important coding interview related playlist to help you in your interview rounds. The name of that playlist is Leetcode and Leetcode Solutions. We have compiled more than 250 most frequently asked very important coding interview problems for you under one playlist here. Those problems got asked by big companies including Google, Facebook, Amazon, Apple, Microsoft, Yahoo, Uber, Lyft, LinkedIn and many others. Many times in their interviews. So those are very important coding interview problems. Make sure you go through those problems, understand the logic behind the solutions. If you go through those videos, you are going to learn a lot about data structures, algorithms, problem solving, logic building, as well as Java programming and coding. It will also help you learn lots of new techniques of problem solving that you can use and apply in your interview preparation process. You are also going to learn a lot of Java programming and coding on this channel. You will also come to know about what are the frequently used Java classes and APIs that we often need during the implementation of different concepts and different solutions. So it's going to help you a lot in your interview preparation process. So make sure you check out all those videos. The name of the playlist is Leetcode and Leetcode Solutions. Now, if you are a fresher, junior level developer, you want to practice more coding problems. To help you in your practicing purpose, we have created 3 other playlists on this channel for you. The names of those playlists are Code Forces, Code Chef, Coder. Code Forces, Code Chef, Coder. All in all, more than 800 different varieties of problems are here to help you in your interview preparation and learning process. If you like this video, if you find this video helpful, if this video has helped you in understanding how to implement this memory allocator, then please give it a thumbs up to the video, give it a like to the video, subscribe to this channel. Subscription is very important because that's how the videos can reach to other people, so others will also be able to watch and learn from these videos. So if you like this video, then do subscribe to this channel, give it a like to the video, share this video with all your friends. So your friends will also learn coding, programming, data structures, algorithms, problem solving, logic building and Java coding from this channel. On this channel, you will see lots of solved problems explained with examples for your easier understanding, including graphs, matrices, binary search trees, different algorithmic problems including depth first search, breadth first search, cadence algorithm, binary search algorithm, Kruskal's algorithm, Dijkstra algorithm and many more important algorithmic problems. There are also lots of important data structures related coding interview questions here, including stacks, queues, priority queues, hash table, hash map, tree set, hash set, linked hash map, linked hash set, as well as many more important data structures and logical coding interview problems. So if you are preparing for any coding rounds of interviews or Java rounds of interviews, this channel can definitely help you in your interview preparation and learning process. So please subscribe to this channel now. Also share this video with all your friends so other people will also be able to watch and learn from this channel. If the videos on this channel are helping your learning process, you are learning new techniques here, you are learning more problem solving using different data structures, algorithms, Java programming and coding, then do mention that into the comments. Your comments, your feedback, both are very important for us. That increases our motivation to create more quality content. So if this content is useful and helpful for you, then do mention that into the comments and share it with all your friends. Keep learning, keep coding, keep solving more varieties of coding problems, and most importantly, keep your learning process going on continuously. And thanks for watching these videos.